Hi there, everybody. This is kind of day 3 of our volumes of revolution, our volume journey. Second day when we're doing volumes formed by rotating objects around a certain axis. Yesterday we did disks. Today is the washer method, and very similar to the disk method, except you've got a hole in the middle of your disk. You've got a hole in the middle of your disk. It is called a washer. Here we are taking this region between F and G here and rotating it around the x-axis. So what we get is, or if you can imagine some washers that look like so. And we got a whole bunch of them that make up this solid. Now, the volume of a washer is really, we're taking the volume of the disk formed by f of x when you're rotating it around and subtracting the volume of the hole in there. So the big disk here is, well, our thickness is an x quantity, so we've got dx. It's a disk, so pi r squared is our area, pi, and then the radius is a y coordinate, so that's f of x squared. So this is the volume of the disk without the hole, the big disk without the hole. And we want to subtract the volume of the hole, which is a disk that's in it. So we're going to subtract same bounds, a to b. They're bounds for x, since our quantity is, or since our thickness is dx. Our radius is from the x-axis to here, and that's a y coordinate, so g of x squared, pi r squared, dx, because the thickness is x, is an x quantity. And when you subtract them, you get the volume of the washer. The integral adds up all the washers, makes them infinitesimally small. Now, you don't usually see this written in this form. You see it written like this. The bounds are the same, and they both have pi's in them. So I put the pi on the outside. It really doesn't matter. But the bounds are a and b, and f of x squared minus g of x squared, written as one integral, and then dx. Are these dy sometimes? Yes, they are sometimes dy. You'll see how to figure out whether it's dy or not here in a second. Let's take a look at a couple examples. Okay. So here we've got a region defined by y equals x squared, or between y equals x squared and y equals 2x, and we're going to rotate that around the y-axis this time. So it's going to go this way. So we've got to imagine this rectangle here being going to rotate it around the y-axis. I'll attempt to draw it here. I'm not going to do a very good job. So there's kind of the top of one of our washers. That is a horrible drawing. There's the top of one of our washers. So let's see if we can set this thing up here. Now the thickness of this washer is goes up and down. So that is a y quantity. That means this is going to be dy. Therefore, our bounds are going to be for y also. Now, our region goes from here up to 4. You can confirm that by setting 2x and x squared equal to each other. You'll get x equals 2. And plugging it into either one of these gets you y equals 4. Okay, but our bounds are from 0 to 4. Bounds for y, since it's dy. Now, it's the outer radius squared minus the inner radius squared. And I didn't stress that up here, but here it was the top one squared minus the bottom one squared. But really, it's the outer one squared minus the inner one squared. Now, our outer radius is the distance from here, where we're rotating, or the axis we're rotating it around, out to this outer function. Now, that is an x coordinate on this parabola. So let's see. I'm going to write x squared minus. Now the inner radius is an x coordinate on the line Now, we need these in terms of y, because we're integrating dy. This x was on the parabola. That means we've got to solve for x here. We get the square root of y. So if you solve, you get the square root of y squared. And the inner radius is an x-coordinate on this line, which is, if you solve this for x, you get y over 2 squared. And I almost forgot that pi. We need that pi in there, remember, because we're talking about circles here. And the area of a circle is pi r squared. But in any case, that is the volume of our solid with cross sections that are washers. Now we can go a little farther with this. Let's see, 0 to 4. Square root of y squared is y minus y squared over 4 dy. You can antiderive and find your volume. Let's rotate this around a different axis. Let's say we rotate it this time around y equals -1, which I've had drawn here in black. Okay, so this time our washer is going to look like this. So the thickness of our washer this time is an x quantity. It goes left and right. It's an x quantity. So this time we're going to be integrating dx. Okay, that means our bounds are for x. We're going from 0 to 2. Make sure we have our pi out here. Now it's outer radius squared minus inner radius squared. Now we've got to be careful here. Our outer radius is the distance from the line that we're rotating it around out to here. Now that is not just a y-coordinate on this line. The y-coordinate only gets you from here to here, because this is the x-axis. Y-coordinate is the distance from the x-axis up to the curve. But we've got to add this to it. So now this distance is 1, right? Because this is y equals -1. This distance is 1. This distance is a y-coordinate. So the whole thing is y plus 1. Now I can't put y here because I'm integrating dx. I need this in terms of x. Now that was a y-coordinate on the line, so that means 2x is y. So 2x. So there's our outer radius squared. Okay. Now our inner radius is the distance from here down to this line that we're rotating it around. Again, that is not just a y-coordinate. The y-coordinate is only from here, the x-axis, up to the curve. But our radius is from the line that we're rotating it around. So this distance here again is 1. This distance is a y-coordinate on the parabola. So the whole thing is y plus 1. But we can't put y here because we're integrating dx. Now this y-coordinate is a y-coordinate on the parabola, which is x squared. So this is x squared, and this is 1. Altogether, that's x squared plus 1. And we're squaring it, again, because it's pi r squared, outer radius squared minus inner radius squared. Now we've got our integral that you can plug in your calculator and figure out the value for.